Hi there. This is a video to explain the differences between a SAN device and a NAS device. First and foremost, both are enterprise grade data store powerhouses for an organization and are tier 1 devices of great importance. They are highly mission critical. Both devices allow the IT team of an organization to organize data and share resources using a centralized and dedicated infrastructure. I'm going to use a mind map to make it easier for me to explain this. I will leave a link in the description. You can use it to download a copy of this mind map if you want to. I have a mind map in front of me and I've chalked out the different attributes of SAN and NAS to explain it better. So this side you have the SAN attributes and this side we have the NAS attributes. So first thing, meaning. What's the definition? What is the purpose of a SAN? It is a short form of storage area network. Of course, it is a network meant for storage in specific. A SAN allows sharing of resources with multiple servers. So you would have multiple servers or a farm or a cluster or a blade enclosure which is connected with a SAN device or a SAN network. It is focused on block level operations. I'll explain more later on in the video, but for now SAN is a block level operation. It allows the attached servers to perform block level operations on the storage volume. What does it consist of? It consists of enclosure. Of course, there's an enclosure which holds the array of disks. It has a set of controllers, probably will be like multiples of 2. So there may be 2 controllers or multiple of 2 controllers, and the controllers are basically the brain of the SAN. They control all the operations related to the data being stored on the SAN. The cache is another important element, an important attribute of SAN. Cache, the more the cache you have, the more the performance you would get. That is the rule of the thumb. Yes, of course, it is a fiber channel network. What it means is that you have FC cables running around between the SAN devices, the SAN switch, the servers which are connected on the SAN network. Everything is interconnected with FC cables. There are exceptions here. I will again talk about it later. Now let's come to the meaning of NAS, the definition of NAS. It stands for Network Attached Storage. Allows sharing of resources with multiple nodes. Now if you look at the definition of NAS, it is Network Attached Storage. The meaning of the definition or the full form of SAN is Storage Area Network. So they rhyme each other, NAS and SAN. If you see, you might feel like the names have been reversed. NAS has been reversed as SAN and something of that kind, but both have very specific purposes. NAS itself is a storage which is then attached to a network, and it allows sharing of resources with multiple nodes. I say nodes here, not servers in specific, because a NAS can connect to any endpoint. It is focused on file level operations. What it means is that you get access to the files, you perform activities on the files, unlike SAN, where you get access to the blocks stored in the device. What does it consist of? Yes, it has the same set of structure like as in SAN. It has got an enclosure, it has got a two or more controllers, it has got a cache, and the arrays of disks on the storage. So these are the main components. There are a lot more components here, but these are the major ones. And yes, it consists of an IP address. It is assigned an IP address because it is on a network. This is your network which is connecting the different devices together. And unlike the SAN, which is a private network, that is a network made from fiber optic cables, the NAS is more on the network which is connected with your infrastructure. The infrastructure, the network which is available to the servers, available to the users, and likewise, connected even on the Wi-Fi. You can access a NAS on a Wi-Fi as well. Now let's come to the SAN part. Server connection. So how do the servers connect to SAN? Because it's a fiber channel network, it requires FC ports to be available on the server to make a connection to the SAN network. Usually there would be SAN switches, which would be the central point to connect the servers with the storage device. So now there's another component here, the SAN switch, which comes in. So your servers would have an FC connection to the SAN switch, and then the SAN switch would have an FC connection to the storage, SAN storage. Now usually the administrators would have multi-pathing setup done so that the dependency on a single FC cable is reduced, and it's like a fault tolerance. It's a fallback for cases when the FC cable malfunctions. Then another routing would be taken up, another routing of FC cable would be taken up for transmitting data between the servers and the storage. Let's come to the NAS side. As I mentioned, NAS can be connected from different sorts of devices. It could be a server, or it could be a PC, a workstation, it could be a tablet, it could be a mobile device as well. So server and endpoint connections, you need network port, of course, or you need to be on a Wi-Fi. Either of these would be good enough for you to establish a connection with the NAS. And of course there's a core switch which is there. Some sort of high performing switch would be there in the data center. I have usually seen core switches in an organization. These are like a central network unit which allows connection from all the servers, connection from different flows, connection from different machines. They all clubbed and connected to the central core switch, and then this core switch allows data to be transmitted between the application, the server, and the endpoints. Let's look at the main purpose of SAN. Why would you want to have a SAN in your organization? The main purpose of SAN is to provide dedicated server space on a shared resource platform. What this means is that SAN centralizes all your storage needs for the different servers you have in the data center. Now when a storage is connected with a server, a specified amount of space is allocated for the server. Now the server owns this space on the storage. This is a dedicated space. It is private to the server. No other server would have access to it. This will be isolated with the server, and the server can perform any activity which is required for the final output, the required output. The file system is again dictated by the attached server. I'll cover this up further down, but basically you will have multiple file systems on a SAN. Again, it's meant for servers, it is good for servers. This is not something which you would connect with a workstation or you would connect with the endpoints. There is no need for it. These are very expensive devices. The intention is to consolidate and centralize your server data storage requirement. Now let's come to the NAS side. NAS is intended for file sharing between computers. That is the prime purpose of hosting a NAS. The intention is to have a centralized storage where the company data can be hosted on, can be stored, and then links or access can be given to end users on their devices. As compared to the SAN, a NAS will allow multiple hosts to access the same file. This is the whole purpose of having a NAS, to share files. It is good for file servers. It is good for having backup being done on the NAS. I've seen a lot of organizations do backup of all the other servers on a centralized NAS, and obviously the public drive or your internal company drives are shared on the NAS. Coming to the next attribute now, file system. Now, what kind of file systems are supported on SAN? As I mentioned earlier, it depends on the connecting server, what operating system you're hosting on the server. That would determine what kind of file system you would like to create in the allocated space on the SAN. Now, specific to the server operating system, so there are many kind of different file systems which are supported by a SAN. If you're hosting a Windows operating system, you would go with NTFS. If you have a Unix operating system, you would prefer looking at UFS or ZFS. If you are hosting Solaris servers, you would definitely look at ZFS, Solaris or Linux. Now Linux also uses ZFS. Very specific to Linux, if you have a Linux operating system like Fedora or Red Hat or Ubuntu, you would look at ext3, ext4 file system, or something like RazorFS. Now there are multiple file systems. You can look at the SAN documents to find out what all is supported. Ideally, it should not make a difference, but it would be best practice if you can look at the documentation before investing on such a product. Now coming to the NAS side, file system is independent of connecting devices. So you can have one file system on a NAS, and what file system that should be will be determined by what kind of protocols you want to enable on the NAS. What are protocols? Protocols are basically like the software layer which allows different devices to talk with the NAS. The different ways of sharing files, the different protocols which allow sharing files. Now it all depends on what kind of protocols you want to support on your NAS device, and that would determine what kind of operating system you would like to host on the NAS. I have personally seen Linux operating system. I have seen Windows doing very well. The choice is completely yours. Recently I've seen organizations using ZFS as well because of the ruggedness of the operating system, the ruggedness of the file system. So it's a choice. It again depends on protocol. Now let's look at the protocols. What protocols are required and what protocols are supported on a SAN. SAN is primarily FCP. This is the fiber channel protocol. So because of the fiber cables running around, FC protocol is what is supported on all the connecting devices, as well as the, the SAN switches and the SAN storage itself. On the NAS side, you have multiple options. Because you already have a file system on the NAS, you will enable these protocols on the shared volumes to allow different kinds of devices to connect. So the most popular NFS protocol is widely used and specially required if you want to connect between different operating systems like Unix, Linux, and Windows. If you want to interconnect, NFS is a very good protocol. Then you have the standard FTP SFTP protocol for transmitting files from and to different nodes. SMB protocol, which is widely used on Windows operating system, again good for sharing files. CIFS. CIFS is basically a dialect of SMB, but again it's a popular protocol for sharing files, accessing files. Now let's look at the last attribute on my list, disk types. So what kind of disks are used on these storages? When we buy a SAN, we buy with the intention of having good performance, and that can only be achieved by having SAS or SSD disks. For NAS, there are multiple choices. You can go with SAS, which are kind of expensive. If you're looking at performance on a NAS, yes, SAS is a good option. You can go with SATA, which are cheaper devices, cheaper hard disks, or you can go with NLSAS, which are slightly better performing than SATA, but not as good as SAS. So it's a trade-off. You have to choose between these kind of hard disks based on what is supported on the NAS box and how much you want to invest in this. Now with the advances in technology, the the differences between a SAN and a NAS is sort of getting diluted. You can find a box which acts as a SAN as well as a NAS. It supports both set of attributes. I'm putting in some more points here so that these are the trends which have come up, and it would be good to know because there's a very thin line now between a NAS and a SAN. Yes, the properties we talked about still exist, but it's hard to differentiate when you look at a box. As I mentioned, a data store can now be both a SAN and a NAS at the same time. So there could be a box we look at, and it could be connected with FC cables. It would have a network cable, and that would mean that it is on the network. It can allow connection on the network to certain set of its volumes. At the same time, it has got dedicated volumes which are connected with servers using FC cables. Both SAN and NAS, both kind of boxes or combined set, both can be scaled using expansion boxes. These are enclosures which come with additional set of disks, and they are again controlled by the controllers present in the first box. So you can keep on attaching these expansions and expand your storage space. There are some unique network protocols which are again used on both NAS and SAN, which again dilutes the differentiation we talked about. iSCSI and FCOE. I believe there are other protocols, but these are the key ones. Well, this sums up my mind map. What I'll do now is I'll do a rough sketch of how a data center setup would look like with the NAS and a SAN device in place. This is a hand-drawn rough sketch of how a data center would look like. This is a standard setup. There could be different kinds of setup. I'm just talking about the most conventional one. Now let's start with the servers in between. Let's say this is a rack of servers. Could also have an enclosure of blades. Sorry about my drawing. Can probably add one more server here. Now the right side, let's say we will we'll add a SAN network. These are basically FC switches. This is the SAN storage. The device with the controllers and the hard disks. Just to make it more clearer. Now what would happen is you would have FC connection between the server to both the switches. Just for the sake of clarity, I'm just keeping two switches here. Same would apply to server 2, two FC connections, server 3, 4, and of course the blade enclosure. Enclosure might have two FCs on each of the switch. Now what would happen from the switches, you will have an FC connection to each of the controller. Let's say this is controller 1, this is controller 2. You can add more to create a more thicker mesh. This interconnection of FC cables is required for multipathing. As I mentioned earlier, if one of the cable connection fails, the traffic will be routed to the alternate cable which is available now from the server or from the switch. This would be a typical SAN setup. Now let's look at the NAS side. For a NAS, you would have network switches in between. We'll call it as core switches. Now each server would be connected with multiple connection, again creating a fallback mechanism. Between the servers and the core switch. Now the core switch, just like you have servers, blades, would also connect with a NAS box. You can see this is FC network. That is a fiber channel network. This is your IP network, or simply the network which is allowing multiple devices to connect. Now what happens is your core switch is also connected with a bunch of other networking devices. So these are basically the LAN network switches on the left side. And this could be switches, could be routers, access points. They are interconnected. You might have devices connected to devices, routers, hubs, all intended for spreading the network and achieving the connectivity objective for the business. Now these devices, they allow access to computers, they allow access to tablets, or just your handheld devices. Could be a mobile, could be a cell phone, or a handheld terminal, or a portable device. Now these devices would be connected to your network, and these devices can be given access to your NAS because they are on the same network. Yes, you will have VLANs created in between to isolate your data center traffic from the corporate traffic, but then it's all interconnected and your endpoints can be enabled for access to the NAS, whereas this part is private to the data center. This is within the data center and connected with servers only. So if users want access to data stored over on SAN, stored in SAN, they would usually come through these servers. There would be apps running on the server which are then connected with the storage. Well, thank you for watching this video. I hope this was useful. Well, till next time, see ya.